Good afternoon and welcome once again to Aalto University's public lecture series Internet Forum. And this autumn, as you know, our theme is 5G, what we all have to know. My name is Jarno Limnel. I am responsible for this lecture series this autumn. And like you remember from the last week, the first lecture was given by Harri Holma, fellow in Nokia. Excellent presentation concentrating on 5G with all the possibilities. And we will actually, as you know, continue with the same theme. And I am very happy to introduce this afternoon's lecturer, who is Petri Lehikoinen. Petri is director in Traficom, which is Finnish Transport and Communications Agency. And we are very happy to have Petri here. But before we are going to Petri's lecture, a short reminder to everybody and especially to our students. You can comment, you can ask questions, and please do. I really appreciate it. Last time when you were very active on this, and write these questions and comments to the chat in Zoom. So as you know, you can follow these lectures, live lectures, either via Zoom or via Panopto. It's up to you. But if you want to comment and ask questions, then you have to use Zoom. And for our students, in order to show your attendance, there will be a special code for you put in the Zoom chat, and it will be presented also in Panopto. So you have to pick that code from there and put it to my courses, and in that way show your attendance. And we are going to answer all these questions and comments in the end. Petri will answer them, so please write them and I will raise them up after Petri Lehikoinen's lecture. Warm welcome, Petri, and as we know, you have actually graduated from Aalto University. How does it feel to be back?
Yes, thank you, and thank you for the invitation for this lecture. It's a pleasure to be here. And indeed, quite a lot of things have changed. Well, I graduated in '94. I have been here since that, but it's been maybe 5 years, and a lot of have changed. So it's almost that you don't recognize the place anymore. But I'm sure the work that you are doing here is still excellent. So
we hope so too. Very nice to have you here. Please, Petri, the floor is yours.
Yes, thank you. Okay, so let me check whether this actually works. Okay, now it works. So thank you. I will talk to you about the ways that 5G is capable of changing our lives. So I will bring up certain examples, and I will discuss other things. So basically, first have a look about where we are going in a way, and have some history background about the wireless generations and the communication systems. Then I will speak something about the spectrum area and about the international and regulatory views. Some words about connectivity. Okay, so we continue. So then I will discuss some words about security in the networks, and then have some examples of 5G affects different sectors, or has the possibility to have an effect on the sectors. So the let's say where we are going, or what's all this about. I think one of the critical things or important things is digitalization. And basically that is the incorporation of digital technologies into our business processes. And in a broader sense, incorporation of digital technologies into everything that we do. This digitalization is informative. It changes how companies, public authorities, and all of us work with each other, and it entails redesign of processes. One critical component of this digitalization, or that makes it happening, is the possibility to have a very good and fast and reliable connection, and to have the connection into a really, really large number of terminals. So I was saying that one of the critical components making this digitalization possible is connectivity. And of course, other things such as AI, enough processing power, security, and other things are required to make the future digitalization to happen. In this presentation, I will concentrate more on the connectivity side of the, let's say, wireless generations, and the role of regulation, role of the regulation in that. And I would like to start with let's say, a picture about how we have become here, and you all are quite probably familiar with this type of picture, that we have 5 generations, or 5G. All that started already at the 80s, and when we had the analog NMT network, and that was a revolutionary network at that point in time, because it was the first network to provide mobile connectivity, so that you could move within a city or even within a country. But it was only for voice calls. In the 90s, we had GSM, and that was a digital network providing mainly voice, but it also had a text messaging. So at least the people of my age were very enthusiastic about the text messaging at the time. And I believe in Finland it was many billions of text messages that were sent yearly in the early, let's say, or late 1990s or early 2000s. But the other thing was that the TSM already provided slow data. 3G came along, basically just improving the broadband connection, and one big thing that happened at that point in time was the introduction of the smartphones. So that was a big thing, and it had also, let's say, better voice quality than 2G. 4G, I guess that was a little bit bigger change from 3G to 4G than 2G to 3G, because that was an internet protocol based network, and it provided already quite fast broadband, so up to 100 megabits and more. And now we are here at the 5G era, and we heard a very excellent presentation or lecture last time that basically explained what 5G can do. And of course, it has a really, really fast data, low latency, and etc. Some words about the how we have made it possible to have these different generations. Basically, when you change the generation in the mobile networks, you need a lot of things. And one of the important things that you need is a spectrum. So the first networks, they had a very low capacity, so you didn't really need that much frequencies. But as 4G, and especially now with 5G, you need basically as much frequencies as you can get. And how that is actually done, it's within the international work within these players that are shown now on the screen. So at the top level, you have the global level, the ITU. So basically at ITU level, the frequencies are the the use of the frequencies is decided on a WRC, so World Radio Conference. From there, the frequencies come usable for other parts of the world. So then we have in the middle, we have the let's say the middle layer, we have the European level, and there we have basically 3 players. We have ECC, or so it's European Communications Committee with 48 members. We have EU with nowadays 27 members, and those deal with the frequencies and the ECC mainly about frequencies. And of course we have ETSI that makes radio standards. So they basically utilize the frequencies that are made available by the decisions. Then we have the national level. The communication policy is led by the Ministry of Transport and Communications. And so basically they are responsible for it. And our role at Traficom is basically to manage the frequencies, grant radio licenses, and make decrees. And one of the big issues, things what we do is international work within these global and ITUR level to make the frequencies available. And as I mentioned, I will come back to this in a while. But basically, the World Radio Conference is quite very important, and we put quite some effort to work related to that, because if we want to, let's say, have results that are according to our national goals, we have to influence the international work quite heavily. And let's say the world of frequencies is quite messy. Don't be scared of this picture. You don't have to remember almost anything about it, but it's just to actually show the spectrum allocations for different purposes. And the thing about that is that there are easily more than 20 different user groups or users that want to use the frequencies. And as the time goes, it's more and more difficult to find new frequencies to be used for any purpose. And the work in the WRCs is quite slow. Basically, they happen only every 3 to 4 years. And the end results, basically in this picture, you can see the different frequency bands that are used in Finland and also in Europe for mobile broadband. And there are 2 things maybe from this slide that I would like to point out. As you see, there is in each line there is the frequency band when the frequency band was taken into use or granted here by our ministry, and then there is the WRC and a year. So you can see that the WRC decisions have taken place quite a lot earlier than the frequencies that are taken into use in Finland. For instance, if you look at some older decisions, so we have I guess the largest time was at Clark at 92. There were decisions about the GSM 1800 frequencies, and it took 6 years. Okay, there's an X, so 6 years to take the frequencies into use. Or 2.5 gigahertz bands. WRC international global decisions for that frequency band were made at year 2000, and it took 9 years before they were taken into use in Finland. So it's a long process, and it takes time, and it gets basically more complicated, as I mentioned, because there are more interest in the use of the frequencies. And maybe another point in this band that you can see that since 2009, the frequency bands have been auctioned. The new frequency bands have been auctioned in Finland. Okay, just a few words about the EU side of the 5G. EU recognized early that there is a need to push Europe into taking the 5G networks into use. And especially that meant the frequency part. So the frequencies that are sort of earmarked for the 5G is 3.5, 26, and 700. Many countries around Europe, they had other users on those bands, and they have had a lot of difficulties to reallocate the existing users to other bands. So they came up with the 5G action plan and EU Gigabit Society communications, in which they basically say that all Europeans should have 100 megabits connection by 2025, and that you should have, let's say, a good coverage along the main roads. And to emphasize the timing, EU action plan, there were, let's say, goals that the, let's say, the larger commercial deployment of 5G network should happen to 2020. And to some extent, this is happening. It's really happening in Finland, as I showed you earlier, that we have already given all the frequencies to the operators. But that's not the situation even at this point in Europe. And one of the things that I guess you can say that we have done very well in Finland and led by the ministry, that we have made spectrum available for the operators very quickly, as quickly as possible. Basically there has been auctions, but there hasn't really been any fiscal goals. So we did not make the let's say the mistakes that some countries made with the auctions that gathered a huge amount of money, but the networks did not realize, for instance, in Germany. So we have in this just another representation of the bands in use. And the network coverage in Finland is actually very good. So we have almost 9% of the Finnish population is within the coverage area of the 4G networks. More than half of the households already has 5G coverage already at this point in time. And it has resulted, as we know, we have very good networks and let's say relatively low prices, or even low prices compared to many other countries. We have had or have coverage applications in the network licenses, mainly two. So there's a 99% coverage, population coverage application, but that's, as you can see, that's easily fulfilled with all the operators. The other one that is not quite so fully fulfilled is that there is there is a requirement for rail and road coverage 100%. But one point that you should note is that the coverage applications do not specify any requirements, or there are no requirements for the quality. So there is no mention how many megabits per second it should be. And one important issue is also that all the bands are technology neutral, so the operators can actually use any band for any generation they like, and that's also quite unique situation in Finland. So legislation is and licenses are technology neutral. And also there are some future spectrum available into right lower corner. You can see the 1.5 and the other frequencies, but there hasn't been let's say requirement for those frequencies at this point in time. One of the issues that is quite new, just since last year, we have had specialized frequencies for local mobile broadband. So at this point we have 2 frequency bands that we can have local mobile networks. And one really unique thing that we have in Finland that is not anywhere is that we have made a frequency spectrum available for research, development, and educational purposes. So we have 4 of these mobile bands that there are in certain location and on certain frequencies that the operators cannot actually use. They are reserved for research purposes, and we grant licenses for that use, and they are quite heavily used. And especially manufacturers and research institutes like Aalto have been very pleased that they have the possibility to do different kind of tests with these frequencies. Okay, this I will actually skip very quickly, but the main difference between the local mobile networks is that the licenses for those are granted by Traficom. So it's a quick process. Of course, there are not that many frequencies available. As for the mobile broadband network licenses, they are issued by the government. And this is just another presentation or representation how the frequencies are exactly. But I think what I would want to share with this slide is that Finland has also, if you look at the availability of the frequencies for operators, it's quite unique. So we have per operator, we have, you could say that the most frequencies available, and we have made that possible for all our 3 operators. So they have more than 1 gigahertz of frequencies available for each of them. So that's not really the case in anywhere else. Coverage. Okay, this is just a representation how the fixed and mobile coverage is in Finland. So we can see basically that 93% of the homes are covered with the 100 megabits mobile network, and 65% of the homes have fixed lines. You can see that this is a very good number basically, but it's still short of the EU goals, if you like, that you should have 100 megabits per second by 2025. But it's also with these values, we are in the, let's say, in the middle positions in the world with the coverage, especially with mobile networks. And there is a picture, as I mentioned, there is a coverage obligation for the roads and the rail network also. This shows the coverage that we have 400 megabits per second for 4G and 5G. And as you can see, it does not cover that, but it almost covers it 100% with the slower speed. So we have good coverage on these roads as well. Okay, just shortly about the coverage in general globally. I mean, we are in a very, let's say, good situation in Finland, and we quite often do not recall that if you look things globally, the connectivity is not even close that good. So yes, we have 4.7 billion people that are connected to the internet, but that means that we have 40%, so we have more than 3 billion people worldwide that do not actually have the connection. So that's a huge number. And one other notable thing in this is that most of the people are connected to the network through mobile devices. So 93% according to this. And if you look at the global coverage, if you want to have a global coverage, you basically, it's not going to happen with terrestrial networks. Obvious reasons, of course, that it's quite expensive to build networks. If you have very sparsely populated areas, it's not commercially viable to do that. And of course, if you look at the seas or certain areas that are difficult to reach, like polar regions, you don't have any coverage there. So basically, if you want to do that, you should need, or you need satellites. And with the satellites, you need a limited terrestrial network or infrastructure. But if you want to provide good quality and broadband speeds, so if you want to provide to everyone around the world 100 megabits, you really do need a lot of satellites. And in the past, already in the 1990s and early 2000s, there have been several enterprises or firms that are really seriously been building satellite systems, but they have actually all failed. But now it seems that we have quite a few satellite systems, and I just mentioned here two. We have Spacex Starlink. They are in their first generation of satellites. They are planning to send 12,000 satellites in orbit. And that would provide 100 megabits per second per user. And they have already launched actually 2,000 satellites. So that's actually a very promising start. And it seems that it really might happen actually. And they are providing already beta services around the world, but not yet in Finland, but hopefully soon. And they have even more ambitious plans. In the generation 2, they plan to send 30,000 satellites around orbiting the Earth, and that could actually provide 1 gigabit per user. So they have really, really ambitious plans. And if that happens, then you really have a very, very good coverage globally. The other one that I would like to mention is OneWeb. They have a, let's say, more limited number of satellites, 700, but they also planning to provide 100 megabits connection, but they are targeting not the, let's say, the general population, but more specific groups. For instance, the base station feeder link type of application for 5G. That's doable, or in areas that there is no infrastructure, terrestrial infrastructure. But connectivity is one thing, but what you need basically more, and what you need more really is that you need a system that is trusted and secure. Because basically, if you have a good, let's say, communication system or systems, but if people do not trust it or they are afraid to use it, it's not really going to do well in the long run. So if you want to get the benefits from the future digital society, you need a network that can be secure and can be trusted. A few words about the, let's say, the security side, very, very shortly. Yeah, but there are many ways to discuss about the risk, but one is that you have, of course, within the technology, you have different levels of risks. Basically, with the 5G, you have, compared to the other, let's say, generations, you have fundamentally much more complex system. You have open or virtualized or cloud-based systems and services. You have a different type of infra that is basically shared, but if something is shared, it creates a lot of problems. And if you look at the, let's say, the players that are building the networks, there are also, let's say, variation in the skill sets of what they are capable, or they might have different drivers when they are building the networks. And of course, one of the difficulties with the, let's say, any network that is connected to the public telecommunication network is that, and if you have a very large number of points connected, it opens up more, let's say, places that can be used to breach the network. And one of the issues also with the 5G is the physical protection of the 5G sites. So the technology is very important, and it's something that needs to be, let's say, taken care of, that it works. The other, let's say, part of the equation is also the human side, or the human factor. And basically this is maybe even more difficult to tackle in a way than the technical. I mean, there are difficulties in the technical side. Basically, people many times could say the weak link in here, because we are helpful, we want to feel important, and we basically do not want to have negative consequences. And one of the things is also that we act in a hurry in a way, and do not really, well, at least sometimes we don't think about the consequences. So that creates, if you look at the security of the networks, that creates also a lot of difficulties that needs different, let's say, tools than the technology side. The 5G, as I mentioned, the EU has taken a big interest to introduce 5G within Europe, because they are basically concerned that Europe will be left behind Asia or US. And they have pushed for the frequencies, but they have also pushed for the security side. And they have created a EU toolbox for 5G security. So they have, let's say, set up certain measures or codes that member states should do. So they're basically saying that the member states should strengthen the security requirements for the network, for the operators. They should assess the risk profile of suppliers, and they should ensure that each operator has a multi-vendor strategy, so that they would not be too reliant on just one vendor. And this has basically been done within the EU in the last few years. On parallel with that, we have nationally been also active. So we actually have changed our legislations and made changes to the Act on Electronic Communication Services, basically to say defining the critical parts of the communication networks with the aim that care should be taken that the critical parts of the communication network are secure. And Traficom has also given regulation on that, where we basically, let's say, according to the law, there are some more general requirements. So in the Traficom regulation, we give a more detailed, let's say, rule book for the operators, how they should behave and do, And one of the major things is that they should identify the critical parts or functions of the network. So that's basically what we have done. It has been received quite well, and it's well, maybe the consensus is a bit too far, but it's a good starting point to ensure that our 5G networks also are secure, and we for that reason we have taken or adopted the new legislation. Other type of way that we have done in Traficom is that we have thought about a different way of trying to make the networks more secure. Basically, because the networks have a very large number of, let's say, different layers, a really large number of terminals connected to it. It's easier for the let's say hacker to breach the system, and it's more difficult than in the previous networks, and that leads to at least one thing that is quite important in the networks is that when designing, let's say, software, hardware components within the network, care should be taken already in the design phase to say tackle the security issues. And I guess you recognize that is something called by security by design, and that's very important in that sense. And keeping all this in mind, we have at Traficom created a new type of collaboration between different players in the 5G community, and we have had cybersecurity hacks. So we have created, together with our partners, hands-on testing of 5G in collaborative hacking events with the aim to improve our understanding and capabilities to better secure the digital society. And we believe that this will strengthen the collective 5G security, and by making the areas that are problematic better visible to all, and in that sense it would help the overall security within the networks. So far we have had 2 of these hacks. So we had first in late 2019, just before the COVID, and we had there 3 different, let's say, challenges, and we had about 70 white hat hackers participating in that from around about 15 countries. And then we had a second hack in before summer this year, which we have 4 challenges and better participations around the world. And the results basically were quite positive. We believe that with these hackathons, we have learned quite a lot about the vulnerabilities and security perspectives of these networks and make them visible and available for anyone who's interested. And we have made this, so the Traficom and the National Energy Supply Agency have been organizing this, and we have very good partners with this. So we have, among others, Ericsson, Cisco, and Nokia, and not to forget Aalto University, of course, and also the University of Oulu, 6G. So this was one of our ways that we thought that would be good to try to improve the security of networks. Moving on to a little bit different field is that we also had an idea in 2017 that 5G was not so much, let's say, known or shown, that we established a 5G momentum ecosystem. with the idea that we want to promote the 5G and bring together parties, companies, research organizations that were interested in 5G and provide them information about 5G and just create a place that they can discuss among themselves. So far we have had, so what we have done is basically that we have held seminars and workshops. We have held actually 26 different workshops since 2018 on different items. So basically you can see we have workshops on drones, industrial logistics, and etc. So on many different sectors. We have distributed information, and we have made frequencies available, for instance, for trials, so that interested parties can test different 5G possibilities. And we have about 144 member organizations, and we have almost 1,000 receivers of the newsletter that we are sending. Okay, moving towards the let's say last part of the presentations is about the possibilities, or how does all this actually how all of this will be visible into our lives. So this is just an illustration of the different areas that the 5G will have an effect in future. And I will just give you some examples on some of these sectors. And I would like to start with the transportation and logistics. Transportation and logistics have become increasingly complex over the past years. And basically with the faster data speeds and reduced latency, they will give rise to a more responsive network to support this transformation, and also paving the way for more internet-enabled smart devices. This will change or render the logistic processes faster, safer, and more reliable, and help to predict the future performance and optimize operational efficiency of the logistic chain. Automated vehicles is an interesting topic. There has been, well, let's say, one of the building blocks, of course, for the automated transport system is a smart and connected vehicle. So vehicle to everything communications, what you could call V2X, is a technology that connects the vehicles and infrastructure with each other. With V2X, basically the cars and trucks can communicate with each other, and with smart infrastructure such as traffic lights, improve safety and reduce congestion. This can improve the efficiency of the entire transport system in the future. And V2X can, for instance, create a smart intersection that will allow multiple cars to go through the intersection without for them to need to stop at the intersection. So it will improve the traffic flow. There are still, let's say, things obviously that needs to be done, and one of the things is that the vehicles or the cars or buses and trucks, they need to actually be quite reliable, or let's say very reliable and secure, so that they can also handle situations that there is no, let's say, 5G or any other network available for them to work. So the vehicles have to be able to handle themselves also in the situation that there is no supporting network behind them. And a few years ago, or let's say some years ago, there were actually quite positive views about when the smart vehicles would be available. and a smart vehicle, I mean a fully autonomous car or self-driving car. But nowadays, the consensus, or let's say the majority view is that it's not going to happen in 1 or 2 years. So there's plenty to be done within the cars themselves and also with the communication networks. Moving on, the industry, and if I just from this one take the smart grid, let's say an example. Smart grid is an electricity network enabling a two-way flow of electricity and data. It is one example, or is that if you in the future you will have electric cars, and one, let's say, simple thing for the smart grid to do is to time the charging of the networks. So that's actually quite simple. So that would give the users, let's say, lower prices, and the power charging would happen at the times when there is a low use. But let's say a more complex idea is that how about if you have, let's say, hundreds of thousands of the vehicles and they are charging during the night or at any time. There's actually a huge amount of energy within those batteries. So it's actually a gigawatts of energy if you have hundreds of thousands of energy. So actually that energy in a smart grid could be used to, let's say, if you have a high demand on the need of the electricity in the grid, you could actually take power or electricity out of the car batteries. So instead of turning on some backup generators, you could actually use the car batteries as a backup system. On the smart cities, the European Commission defines a smart city as a place where traditional networks and services are made more efficient with the use of digital and telecommunication technologies for the benefits of its inhabitants and businesses. So that's very, let's say, high level. But in real life, in the cities, we have data from a large number of sensors that collect real-time data to better understand how things within the city are changing and respond to that in various ways. What does all that mean for us? Basically, it means that at some point in future, it is possible to deploy applications that can monitor and control the energy use, traffic patterns, street lighting, smart parking, crowd management, and many other things within the city. And all this can lead to improved traffic and commute time, accelerated emergency response, reduced healthcare, and savings in water and waste and harmful emission. And ultimately, it would save, create a huge saving potential. Lastly, a few words about the smart home or a smart building. And I guess this is the closest thing to us, and at this point, I guess it's maybe better to talk about connected homes rather than smart homes. We all have actually, if you think about it, you already have quite a number of different wireless terminals at your home, but they are not really working that well together. So they are independent from one another, and the data from one system is not really usable in another system. And for instance, in my house or in my family house, I just calculated that we have almost 100 different type of wireless terminals or equipment at the house. So basically, you have your Wi-Fi's, you have your phones, you have your wireless sensors, lights, wireless lights, earplugs, loudspeakers, and different hubs for sensors. So actually a lot of different equipment, but it doesn't really work well together. So hopefully at some point soon we can have integrated systems that can give us, for instance, home security. So basically access systems, alarms, monitoring, etc. Tools for maintenance. And one quite interesting part is that could happen or that would be beneficial is that we could have some health status monitoring because that actually would enable for us to, instead of in certain situations that we, instead of being at the hospital, we actually could be at home and our house would actually monitor us. So there are actually a lot of possibilities within the smart home, but also in all the other sectors that I shortly discussed that are at this point in time not really here yet, but they need a development, and actually time will tell actually how much or what will be possible and how our lives will be changed with 5G. And then I would like to actually end up with this slide to maybe also emphasize the fact that we have been discussing a lot about the 5G, and this lecture series is about 5G and what it can do. But we should keep in mind that the 5G is not, let's say, the ultimate network. There will be improvements to it. So I guess we have the last lecture is about 6G and its possibilities. And even after the, let's say, 6G, there will be 7G and 8G and so on. And here I just put out an idea that we do not forget that everything is changing, and maybe at 2040 we may have a, let's say, fully operational 7G networks, whatever that may be. And with the let's say the future, it's a bit strange. As I mentioned, 2040, it actually seems very far away. But if you think about it, 2040 is actually closer than 2001. So it depends a little bit on your perspective. And of course, this works a bit differently for people of different ages. But it is just to remember that the future is maybe not that far away, even though it seems that 2040 seems to be far off. And with this, I would like to conclude my presentation. Thank you. So now I guess if there are questions, I will be happy to try to answer them.
So I think we have only one mic. Okay. Even if we are talking about 7G, we are still having some challenges with the voices, but hey, that's the technology, and the resilience is needed. Thank you very much, Petri. Excellent presentation. Lot of interesting information, and of course I was very happy that you brought up the importance of the cybersecurity and security, as well as you emphasize it must be integrated whatever we are digitalizing and creating. Well, I have to you, if you allow me to ask a little bit personal question, because as you mentioned in the beginning, you have graduated from Aalto University almost 30 years ago, 1994. And if you think about the technology now in the autumn of 2021 and the situation of the technology at that time when you graduated, what would you say, what has been the biggest change in overall or in general in technology?
Yes, thank you. Yes, I try not to think about that. It's almost 30 years that I graduated, but thank you for reminding me. But yes, it's really sometimes. I mean, you easily actually sort of forget what the life was before, and I guess I mean, just an example. At that point in time, I didn't have a mobile phone.
Mm.
I mean, they were relatively expensive, and well, I was a student, so I sort of decided that I don't need it.
Mm.
And actually, I didn't really need that. But I guess I would say the big change is that how easy it is nowadays to be connected.
Mm.
So the amount of information that is available for everybody that has that connection, and luckily in Finland, everybody more or less have that. So I would say that is really one of the major changes. And it is such a sort of a subtle thing that now we take it for granted, and we don't actually think about it. And of course, with the connectivity and with good networks, we have so many different services, and that you could not even have thought at that point in time. So I guess the internet was more or less just starting to spread out at that time as well. So that's another example that it's hardly used. I hardly used the internet at that point in time, really, because there weren't that much things in it that were. So that's one question.
Thank you, Petri. And once again, sorry for the some challenges with the voices during this lecture. Hopefully we are able to fix that a little bit better for the recording. Let's see, we can see some feedback of the quality of the voice in the chat. Sorry for that, we will do better next time. Question from Henrik Stark. Petri?
Yes.
What has been the biggest security threat in Finland? Like Facebook, Harvard Analytica scandal, etc. or similar. What were the consequences and what has Traficom implemented for that not to happen again?
Okay. That I have to, unfortunately, actually, to admit that I'm not able to give you an answer to that question in a way that it's some. So maybe actually, I think I have someone here standing by me who can give actually a very good answer to this question.
This is yours. So, hey, we will come back to that security theme a little bit later. Keep that in mind. Question, Petri. This is actually pretty good. What I have been thinking as well, from Prince Okomo. Is there a physical limitations to the amount of G we can keep adding? How many G's we are going to face in the future?
Yeah, that's a good question. Well, yeah, I think there's a limitation at some point, but I mean, I think the main difference, if you look at the different G's, is that one of the things that has evolved, and what, let's say, a larger G means that you have larger capacity in your network. So the more capacity you need, the higher you need to go in the frequencies. And nowadays, let's say the highest 5G band is at 40 gigahertz, and there is certain, let's say, short range type of frequencies around 70 gigahertz. But let's say if you want to have 10 times or 100 times more capacity, so if you want to have a terabit of connection, you actually need to have terabit frequencies also into use. So that creates a difficulty technically how to actually do that, because it would also mean that the propagation distances and things like that are actually very low. So it actually depends when having the different Gs, that what are actually the requirements for that. But if you want to have unlimited, let's say, data speeds, you need to go to really, really high frequencies, and that's really, really difficult to do.
Last question, Petri. How would you summarize for average people here in Finland? What is the main consequences of 5G? How we are able to see that, okay, on our daily lives, that okay, now we are living 5G era?
Yes, I think there are many ways maybe to summarize, but maybe a twofold thing is that at the time that you, let's say at your home, if you talk about the mobile connection, that if you have let's say a very, very fast network, so basically if you have, or in other ways says that if you are happy with your connection speed that you are using, and it happens to be mobile, even now if you really make a lot of use of your connection at home, if you have children and you have a lot of users in the house, so 4G doesn't really do that for you in a house environment. So for that you do need 5G, and maybe the other issue is that has maybe not only to do with the 5G network as such, but I think the 5G is also important building block for that when we have the, let's say, self-driving cars, for instance. So I think that's one milestone as well, and that's probably not going to happen so soon. So that milestone, it's, as I mentioned, it's not only dependent on 5G, but it's an important building block for that. So maybe that might happen in 5, 6, 7 years. Who knows?
Let's see. And maybe you saw when you came to physically here to Otaniemi that there are a traffic sign nearby of this building saying that be aware of the robot cars because they are traveling here. Maybe probably we will have more of those kind of traffic signs. Hey, thank you very much, Petri Lehikoinen, visiting Aalto University once again and giving an excellent lecture. Thank you very much.
Yes, thank you.
Very much appreciated. And we will continue Internet Forum online public lecture series with the theme 5G, what we all have to know. And the next lecture, third lecture, will be held after 2 weeks, so 5th October. And the title then is 5G for Industry. And the lecturer is Johan Torsner from Ericsson, Finland. And probably after a week, starting from today, you will get the recording of this lecture to the web page of this Internet Forum. So thank you very much for attending, listening, and sharing questions, comments. I wish you a good week and be safe. Thank you very much.